There were 144 children and 3 times as many adults at a school football match. An equal number of children and adults left in the middle of the match. At the end of the match, there were 7 times as many adults as children. How many children were there at the end of the match? So for this question, notice that they have given us words like 3 times. So this is what we know in the before information, and this 7 times as well. Okay, this is in the after section. All right, so you can actually record down your data in the before, change, after using ratios. Now, 3 times you can write it as a ratio, 7 times you can also write it as a ratio. Now, there is more than one way to solve this question. Some of you, maybe you want to start off with working with the 144 straight. Okay, so there were 144 children. Some of you want to find out how many adults. Okay, so you take like 144 times 3. Now that's fine. All right, that's all right also. So once you have the actual values of children and adults at first, you can still put it down in a before, change, after formats. Okay, so for now, I will just use the ratio way. So I will not bother about the 144 first. I will just stick with the ratio method. So I'll start off with children to adults ratio. 3 times as many adults. Okay, so that means adults will be 3 units, children will be 1 unit. So 1:3. Now, then we have the change. Draw an arrow to show the change. Equal number of children and adults left in the middle of the match. So there's a drop in number of people. Okay, do we know how many children and adults left? We do not know. All right, so children, you can just go a minus question mark. Same for the adults. So these 2 question marks have the same values. Now, and at the end, there were now 7 times as many adults as children. Please keep your ratio headings consistent. If here C to A, keep it C to A here as well. Okay, so now adults is 7 units, children will be 1 unit. All right, so once I've recorded down my before, change, after with my ratios, next thing is ask yourself, what is the common base? Because you have 2 ratios. So second step, identify your common base. Okay, so what is the common base? Now, will children remain the same throughout? Definitely not, because I have a drop in children. Will adults remain the same? Also not, because I have a reduction or a drop in adults. Will the total be the same? Definitely not. My total will decrease because of people leaving the match. Will my difference be the same? Yes, it will be my difference unchanged. Why? Because equal number of children and adults leaving in the middle of the match. So because these 2 are the same values, hence my difference between adults and children, no change throughout. Okay, the advantage that adults have over children will be the same advantage over here as well. All right, so we're going to add in the new categories, difference, and the difference here. Remember to proceed to make them common multiple, times 3 for this, underline your common base. Once your common base is done, everything settled nicely with your common base, you can then go on to work with your 144 children. Okay, so 144 children will be your 3 units at first. Okay, as you can see, this is 3U before. Do not use 1 unit because you have done your common base. Always use the latest units. Okay, because that's the latest units is what you can rely on, not the old ones. All right, so 3 units is 144. And of course, always find 1 unit value. Once you found 1 unit, reread the final question. How many children at the end? So at the end, as we can see, is after, right? At the end, children is 1 unit, and we have already found 1 unit. So that's it, 48 children at the end.